Okay, this video will introduce you to the Boole truth table generator, which is one of the tools available to you and your students. And if you know how to get to the stanfordlogic.edu homepage, it looks like this. I'm going to go to the Learners page, and along the top here we have some different pages available to us. I'm going to click on Tools, and then I'm going to choose the Boole truth table generator. If you need to know how to work this, the instructions can be shown right here. Basically shows you how to encode different operators. But I'm going to just do a very simple operator, and that's one that we've become very familiar with. P implies Q, the implication. Now you can separate these by a space or a carriage return. It just helps me, at least from my way of thinking, to do a carriage return. So I'm going to have two premises here. That is to say, P implies Q and Q implies R. And my conclusion will be P implies R. So if you push the button truth table here, it will automatically generate the truth table for that. So let's talk about some benefits to this and how you might use it with your students. So one benefit is it automatically separates the constants from the premises and the conclusions, and it will automatically generate the right number of cases. It will then automatically populate the cases in such a way that you get every possible combination. And so what I recommend is that you don't show this to your students until they become proficient at doing it on their own. They should be able to do anything anywhere up to, let's say, 5 proposition constants. And obviously 5 constants would take them to 32 rows. That's quite a bit. You might want to do 6 just to see how they can organize things. But whether it's 5 or 6 proposition constants, as soon as they can master that or get close to mastering it, then show them this tool, because they're going to start to become rapidly aware of the fact that truth tables, although they contain a lot of information, are highly impractical once you go beyond about 4 or 5 proposition constants. And if you get to 10, it's unthinkable almost, because that's 1024. I think that's 2 to the 10th power. So you're not going to make 1,024 rows, and if you do, you're going to probably start making mistakes. So this truth table generator is a very good way for students to be able to check. Now, the majority of the work that students will be doing will be with 3 proposition constants or fewer, and so they'll almost always have 8 or fewer rows to consider. Occasionally you might have them have 4 or 5 constants, so maybe as much as 16 or 32 rows. Okay, enough of that. That's just my thinking. How you decide to introduce it to your students, that's completely up to you. Some of them may discover it on their own and they'll feel like they've got, one over on the class. I've had that happen, and I just don't advertise it until I'm ready to introduce it. So what's the advantages here? Notice that the premises that I entered are here. And you might ask, okay, so what's the benefit of having this truth table? Well, if we want to know, are the premises entailing the conclusion, then I'll look at any place where the premises are both true. For example, here, and the conclusion is true. Not here, not here, not here. Yes here, and the conclusion is true. Not here. Yes to the last 2, and each time the conclusion is true. And so, based on our understanding of entailment, we could say, oh, these premises entail that conclusion. Very interestingly, and one of the best parts about this tool is then to ask yourself, does it work in reverse? What I mean by that is, if P implies Q and Q implies R entails P implies R, does P implies R entail the other 2? So let's take a look at that. I can enter P implies R as my premise. I can enter P implies Q, and Q implies R. Now generating the truth table. I really haven't done anything except switch the columns around. But notice now, it allows me to say, okay, entail means anytime the premises are true, are the conclusions true? Here, yes, but here, no. And also notice, here, yes, but here, no. And so, what do we end up concluding here based on this information? I think we conclude that P implies Q and Q implies R entails P implies R, but P implies R does not entail the other two. And that's an interesting thing to note. So the Boole truth table generator gives you the freedom to create truth tables quickly. It's a tool that your students can use to think quickly, and I recommend that you don't use it until they are good at making their own truth tables, at least through 3 proposition constants. Just a recommendation. You make that decision on your own.